This is question number 7. The parabola shown in the diagram has equation y equals 32 minus 2x squared. The shaded area shown in our diagram in red lies between the lines y equals 14 and y equals 24. We're asked to calculate the shaded area. So we should recognize that this question is going to be an integration question, but we should also see that it's going to require more than one step. If we consider, first of all, the area between the curve and the line y equals 14, we'll show that in blue. It is clear that the shaded area we require is part of this blue area. If we consider now the area between the line y equals 24 and the curve, and this time we'll show this area in green, then hopefully we can now see that the shaded area we require is simply the difference between the blue area and the green area. That means that what we need to do in order to solve this question is find the area between the curve and the line y equals 14, the blue area, and then the curve and the line y equals 24, which is the green area, and then we will subtract them to find our shaded area. So first of all, we'll consider the blue area, the curve, the area between the curve and the line y equals 14. Before we can work out this area, we must figure out the intersection points where the curve meets the line y equals 14, and that will give us our limits of integration. So we have the equation of our curve. The equation of our curve is y equals 32 minus 2x squared. We want to find out where this curve intersects with the line y equals 14. So we simply substitute y equals 14 into our equation. So 14 equals 32 minus 2x squared. So rearranging this to put the letters to the left and numbers to the right, we have 2x squared is equal to 32 minus 14, which means that 2x squared is equal to 18. That means that x squared is going to be 18 divided by 2, and 18 divided by 2 is 9. So x squared equals 9. We want x, so x is equal to the square root of 9. And square root of 9, we should hopefully remember, the square root of 9 has two answers. It's either x equals 3 or x equals minus 3. So what these two values are, these are the x values of the points of intersection here and here. So if we have a look at our curve again, we'll have a look at the area that we're trying to find, the blue area. So in order to find this blue area, we have to integrate between our two limits of our integration limits, sorry, which is 3 and minus 3. So we'll set out our integration. We're integrating between 3 and minus 3. Now it's the area between the curve and the line. Now it's going to be the curve, take away the line since the curve represents the upper boundary. So the curve had an equation 32 minus 2x squared. We're taking away the equation of the line, which was simply 14. And we're going to integrate that with respect to x. So that equals 32 minus 2x minus 14. I should have said 2x squared there. 32 minus 2x squared minus 14 with respect to x. So if we tidy that up a little, then that means that we're integrating between 3 and minus 3. 32 minus 14 is 18 minus 2x squared. So we're now ready to integrate. So first of all, 18, when we integrate 18, that just becomes 18x. Then 2x squared, well, we need to add 1 to the power, which makes it x cubed, and then divide by the new power. And remember, we're integrating between 3 and minus 3. So what we need to do now is put down 2 separate brackets. We're going to write our expression here in both brackets. In the first one, we substitute 3, and in the second one, we substitute minus 3. So 18x in the first bracket is 18 times 3. Take away 2x cubed, so that's 2 times 3 cubed over 3. In the second bracket, same again, only this time we're substituting in minus 3 or negative 3. So when we do that, we get the same thing again, only with negative 3 in the brackets. If we work this out, 18 times 3 is 54. And then if we do 2 times 3 cubed and divide by 3, if we go ahead and work that out, then we find that the answer is 18. And then we're going to subtract our second bracket, so 18 times minus 3 is negative 54. And well, it's negative times another negative, which means it's going to be positive. And then if we work this out, we find that our answer is 18. So 54 take away 18 in the first bracket is 36. Take away the second bracket and it's negative 54, add 18, which is negative 36. So we have 36 take away negative 36, and if we do that, then we get our answer, which is 36 plus 36, which is 72 square units. Now, what we have here is the blue area. What we have to do next is the same thing again, but this time the green area. So we'll go on to a new page for this. So before we can find the green area, we need to find out where the line y equals 24 intersects with the curve. So we can clearly see that the green area is smaller this time. So we're looking for the x values of our intersection points so that we have our limits for our integration. So same thing as before, we write down our equation of our curve, y equals 32 minus 2x squared. This time we want to find out where it intersects with the line y equals 24. So we substitute 24 in for y. So that's equal to 32 minus 2x squared. Rearranging this to put the letters on the left and numbers on the right. Negative 2x becomes 2x squared. Negative 2x squared becomes 2x squared, I should say. And we have 32 remaining on the right hand side, and it's take away 24. So that means 2x squared is equal to 8, which means that x squared is equal to 8 divided by 2, and 8 divided by 2 is 4. So x squared equals 4, which means that x is equal to the square root of 4. Again, the square root of 4 has two answers, one positive and one negative. So that's x equals 2 or x equals minus 2. That means we have our x values which give us the limits of our integration. So now we need to set up our integration. So this time we're integrating between 2 and minus 2. Again, if we look at our curve, the curve represents the upper boundary, so it's going to be the curve take away the line. So if we set that up as follows, we have our curve take away our line. So if we simplify what we have, then that's 32 minus 2x squared take away 24, and we're integrating that with respect to x. So tidying up and simplifying what we have, then 32 minus 24 is 8 minus 2x squared. Now we're ready to integrate. So first of all, integrating 8, that just becomes 8x, and then 2x squared, so add 1 to the power, which means it's cubed now, and divide by the new power, which is 3. So again, what we need to do next is write down two brackets. We're going to write down our new expression in each bracket. In the first bracket, we will substitute in 2, and in the second bracket, we will substitute in minus 2. So in the first bracket, 8 times x is 8 times 2. And the top line of a fraction is 2x cubed, so that's 2 times 2 cubed. Second bracket, we substitute in minus 2, so that's 8 times minus 2. And it's 2 times minus 3 cubed over 3. So working that out, 8 times 2 is 16. And then this fraction here, 2 times 2 cubed over 3. If we work all that out, we find that the answer is 5 1/3. Take away the second bracket, so 8 times minus 2 is minus 16. And working out our second bracket gives us plus 5 1/3. So if we simplify each of the brackets, 16 take away 5 1/3 is 10 2/3. Take away the second bracket, negative 16 add 5 1/3 gives us negative 10 2/3. So we have 10 2/3 take away negative 10 2/3. So that's the same as adding, which gives us 20 4/3. And 20 4/3 is 21 and 1/3. So that's the area of the section shown in green. So if we refer back now to our original diagram, we were looking for the shaded area, which is shown here in red. So the shaded area was equal to the blue area, take away the green area, and the blue area was 72, take away the green area, which was 21 and 1/3. So 72 take away 21 and 1/3 gives us our answer, which is 50 and 2/3. And we have square units. So that's our final answer, the area of the shaded section.